Maybe people can fill in closer. So we're going to do a choose your own adventure. If this talk sucks, it's your fault. So if you leave here and you say it sucks, it's only because you made it suck. So the way we're going to do this is I'm going to set up my environment the best I can, and then I'm going to show a few things that I think will help with creating microservices from the infrastructure perspective. There's lots of things you can do from the application perspective, but I think there's a big disconnect between your application and what Kubernetes does. Some people have this belief that if you put your app in containers of Kubernetes, your app is going to get better. Yeah, you're laughing. You should laugh, because that is so far from the truth. Now, there are some contracts that Kubernetes provides that your app may not be doing that will make things slightly better. So I'm going to start by setting up my environment. I'm going to show some basics of what's going to be in that environment. And then we're going to have some people tell me what they need to know. So what's on my table so far is things like Vault from HashiCorp for secrets management. We'll also be talking a little bit about Istio in the context of Kubernetes and how you should manage your stuff. Okay? So what I'm going to do, and just silly of me, I'm going to bootstrap my small dev Vault cluster live, and then connect it to integrate with Kubernetes, and we'll talk about how your app can actually use it to talk to a database. Okay? And then with Istio, we're going to talk about some of the policy enforcement. There's parts in Kubernetes that are missing, and they're filled by things like Istio. Okay? So we're going to see what that fits in. But you have to actually do something. So if you plan to just check your email, you can continue to do that. But if you have real questions, we're at a conference with real people, so you can ask a question, and I'm going to try to answer your question live. Keep it short, though. We don't need like your background or where you're from. We can do that afterwards. Does that sound like a plan? All right, if it sucks. All right, so we're gonna start with this. The reason that Kubernetes becomes important for people is not because, well, a lot of people are using it as a DevOps tool, meaning people that currently have automation. If you were in the keynote, we talked about automation versus orchestration. There's a contract missing. Okay, so if you're a developer and you build apps, it's really hard to go to a team and say, deploy this app and hope that they get it right, and then you do this joint debugging. Okay? Knowing that's DevOps, okay? Group therapy for sysadmins. This is when we debug together. Some of it's unnecessary, okay? So we have the container as a contract. And then you also now are tasked with having that app deploy multiple environments. So don't worry about the fact that I'm using Google Cloud. Let's focus on the fact that I'm using Kubernetes. The APIs are all the same. So you can run this in your data center. You can use Minikube on your laptop. But now that we have these Kubernetes endpoints, we're going to talk about how do you run your app across all of these 3 clusters. Anyone here, just be very honest, have the ability to deploy their app anywhere, any country, any provider, super easy. Oh, there's one person. Cool, come here. Come on. You better hope you're not lying, because your coworkers are like, we actually don't. Where do you work? Did you quit? Come on up here. Just jump on the stage. If you fall, we have no insurance. All right, cool. Tell people about your environment. What's your name?
John Johnson.
All right, you got you. Oh, you're at work at Google.
I do.
Come on. What the hell is this? All right, go ahead and tell us about it, though.
Oh, it's good. It's called Borg.
All right, tell people about it a little bit.
It's magic. You just like tell it, I want to run in this part of the country, and it magically does it. It's kind of like Kubernetes, but better. But also, it's getting there, and some stuff like Istio has me really excited because I want to play with that on my own. But Kubernetes doesn't have that, whereas I kind of have that stuff internally, and I'm thrilled. I want to play with it. That's all I got. I wasn't ready for this. You just pulled me up here.
You did a good job.
Okay.
So, are you a developer?
I work on GCR.
Good. Ooh, I like that. Cool. So, what is your dev workflow when you build something and it gets deployed wherever you want it?
It takes forever. It's awful, actually. So because we don't want to break y'all, we have to deploy over like a week.
Tell people about the process. This is important.
The process?
Yes. Not the details, but why does it take a week and what is that called?
Okay, so we have like a suite of unit tests and we have a suite of integration tests, and those like kick off all the time.
You still need tests with containers.
environment when we deploy to the production environment. Much like Kubernetes, actually, it looks very, very similar, right? You kick it off and it rolls out and it does like a blue-green deployment. And if anything goes wrong, we get alerts and it like stops and halts and tells us. But it's mostly just automatic, right? We just write our code, we commit it, tests are built, tests are run, and it all just works. It's magic.
Awesome. Give it a big hand. So yes, at Google, if you're like an ops and you think about bringing in one of these tools, no one actually cares about the tool directly. Like if you ever use Kubernetes, I'm going to show you a little bit here. Like you say, oh, I want to teach my developers Kubernetes. It's actually not the best idea. Your developer wants to write apps. They want to build apps that can then be deployed anywhere in the world. So he works on GCR, Google Container Registry. That's a global service, okay? When you write container images and you store them there, they can go anywhere in the globe, mainly because the system underneath takes care of all of that. The ability to do these canary rollouts, I think, is very powerful, and this is one of the things that Kubernetes gives you. So when people say, why Kubernetes, you want this ability to trust a platform, not necessarily tribal knowledge. So when I was a sysadmin, you knew who to ask to do a certain task because that person would probably get it right. Depends on who do it, it may not be right. Like some people are shaking their heads like, hell yeah, never ask Bob. It's not going to work, right? So we want this environment that we can actually have a common target so that way we can just focus on building things. So from the microservices standpoint, a lot of the hard parts about microservices, we don't necessarily solve in the Kubernetes layer. People say Kubernetes is like Borg internally. Unfortunately, at Google, there's a lot more missing pieces to Kubernetes to actually make all this work. We need to have things like metrics, HTTP traces, centralized logging. How do you roll forward? How do you roll back? How do you actually do canary patterns? Containers and Kubernetes do not give you that out of the box. We need more pieces. What about secrets management? How many people manage secrets with config management today? Keep your hand up if you care about security. So there's a disconnect. Wait a minute, for all the other people that didn't raise their hand, how the hell are you getting secrets to your apps? Someone yell it out. Can't tell you. Anyone that says that, they are copying files to servers. I promise you. I worked in financial, I know. If someone can't clearly tell you, because honestly, just you telling me how you put a secret to a server ain't a secret, right? That is not where the secret sauce is. You should be able to audit this. You should be able to tell anyone this is exactly how that gets to that server. And I know exactly what's in there. So today, we're going to get to this in a minute. This is all ground knowledge for like these microservices. Everyone says, I want to do microservices, and there wasn't enough hands around automating even the fact of how you access other services, how you deal with authentication. Like, I think people are jumping the gun a little bit here, all right? So we're going to talk about using something like Vault to actually manage some of this identity stuff that we have. Then the reason why we're going to have to introduce Vault here is that these microservices that you're going to build, this off service, this front end, this back end that does God knows what, this thing that sends email, how do you identify them? Once you identify them, how do you decide which ones get to talk to the database? Right now, people copy files to servers. If you can read the file, you get database credentials out, and you get to talk to the database. This ain't very secure. So we're going to start to show a slightly better way, okay? So we got these clusters. And what we're going to try to do now is deploy some apps, but we need some low-level things here. So having this, we at least have centralized logging. Kubernetes will give you this out of the box. We are going to have some basics about how to keep our app running, so this is great. We talked about earlier in the keynote about the price of admission being the container image. Do we all agree that the container image is a good thing to have? Who isn't sold yet? Be honest. Who isn't sold? Everyone thinks containers is a good idea? Like, you are at Google. Anyone that doesn't think this is a good idea, I need it.
Our bosses.
Huh?
Our bosses.
Your bosses think it's a good idea. They don't think it's a good idea. There's no one here that doesn't think containers are... They don't know one? You all drunk the Kool-Aid? I actually don't think containers are actually that great. I think they're actually silly. Why? Why do we have them? Let's look at it. Why do we have it? We have it for this reason. You guys ready to see this Docker file? Okay. Who's a Python developer? Partly your fault. So don't worry, the license header dominates this source tree, okay? Very simple, we'll walk through this. This is the microservices crowd. This is what they believe is simplicity. Some of us are moving to microservices because we believe that the code bases are going to be easier to deal with, okay? So you have this from Flask. What version of Flask is that? What's that? Okay. And yeah, it's a simple app. Oh, this is funny too. This is really funny. App.py. It doesn't work. So again, we spent the whole industry trying to fix this problem. One would be, let's make another package manager. Every language needs their own. So that helps. What version of Python do we need? No one uses Python 3? They should just start over. So then we try to fix this problem. Here's how we fix it. We're going to bring in a whole operating system, 1 gig. Then we're going to install the internet. Then we're going to copy in the requirements.txt, and then we're going to copy in our app. And our app is a whopping, hold on, /h. Our app is a total of 826 bytes of source code. Great. So this container is going to be about 2.7 terabytes in total size. And we did this because a group of people agreed that dynamic linking was better than static linking. I mean, I traced back the mailing list a long way, and they were like, people, you can't fit the whole app on a floppy disk. It's 2017. I promise you, you will never have to distribute the app you're building on a floppy disk. If so, Red Hat is hiring. There's a bunch of people hiring right now. So in my world, it's different. So in my world, and I think language runtimes will have to change, and this is what the microservices community should be talking about, and we're going to get to why in a moment. Yeah, we'll go to, hey, where's it at? Oh, I got it, CT Go. So I'm a Go developer. How many Go developers are here? Make noise. You're lying. You're going home. Going back to write some JavaScript in a minute. Nothing's wrong with it. Imagine if we all could build like these statically linked Go binaries, right? Where you just have this one artifact where all your dependencies, no libc requirement, all you need is a kernel. If every language worked that way, do you think we would actually have container images? Who think we would have container images if everything, including the runtime, was statically linked? You do? So everything you're saying right now is this tribal knowledge, right? Install this base OS, install this Python version. Honestly, give me this binary. The OS knows what to do with the ELF binary. Just give me that, we're done. Like all languages, if you can give me an ELF binary to execute, we're done. So we went down this path of creating a bigger statically linked thing, a tarball, with all your stuff in it in a root file system. So we made life a little bit more complicated, okay? So moving on. The container image is a necessary evil because static linking is bad, so we're going to do static linking with tarballs instead. Okay, so we move the discussion on. The next thing is, you have your app and it's an independent package thing. We need to describe how it runs. So one thing we're going to do is, I'm using gRPC. How many people have used gRPC at all? Not a lot of people. I'm no longer convinced of all of the benefits unless you really have performance problems, okay? So most of you, how many people are actually doing microservices? Keep your hand up if you like it. Ah, what I expected. The monolith was good. It worked at least. So we're going to talk about the problems with the microservice. All right, so now that we have these individual containers, we actually need to describe how they run. So I'm going to show you how I package my things. To me, this is the price of admission if you want to do microservices or even have a chance. This is the minimal. Number one, I need to know what your requirements are. How many people know the actual CPU and memory requirements for their app to perform at various, maybe, requests per second? You know them. There's 3 of you. If you're going to try to take your monolith that is working, where your paycheck comes from, and you're going to split it into smaller pieces, and then connect them back together with JSON, you need to know this piece. This is one of the things that bite people first. Most people are deploying their app 1 per VM, right? And you can get really far with that pattern. But if you try to come into this container world without giving these things shape, they're going to step all over each other. And it's going to be horrible for you. And it's unfortunate that most people skip this part because they believe that someone else is going to manage it. I need to know what your resource requirements are. That's step 1. You should at least know this. If you don't know this today, how do you find out? How does anyone find out their current resource requirements? How'd you do it? What'd you say? When it breaks. Okay, that's. And when it breaks, you do what?
Scale something up.
You scale. Okay, that is a pattern. You can wait and scale it up. How do you do it? Load testing.
It's something and then it falls over, you add more.
Damn. Okay. Anyone ever use like metrics? I'm gonna let you in on a secret. This is serious. You can actually measure the memory and CPU that your app uses. The next meeting you go to internally about microservices, I'm straight up serious. You can just stop the whole conversation. If someone can't tell you what the memory requirements are for the services, this is like serious business. Like people wondering why for the last 8 years this industry's been talking about microservices and can't pull it off. You have to be able to see. We're gonna see this in a minute. One way you could do it is run your current apps and measure them. Metrics. Get something from the kernel. At least see what you're currently doing over maybe a 3-month period, and then you can just say, we're in this ballpark. Step 1, gotta do it. This one, this is what is that? Raise your hand if you have help checks on your apps. Fantastic. Where's the guy when it breaks? Do you got help checks? When'd you put him in there? I like that guy. That is a good pattern. If you have to determine priority on which ones get help check first, when it breaks is probably the first one you need. Kubernetes expects that you're going to have this health check. You notice we have 2 of them though. We have a liveliness probe and a readiness probe. Anyone know the difference?
The readiness probe, the liveness probe checks to see if the pod is available. Because if it dies, then it can regenerate that.
Okay.
The readiness one lets you know when the pod is actually ready to be served.
Good answer. That's close enough. So the answer here is liveliness asks, are you even alive? If not, I'll restart you. Like you're frozen. You can't do anything. You can't recover on your own. Is the only time that should ever be used. So if you have an app that can't be restarted without, doesn't clean up its database connections or something bad will happen, you don't use the liveliness probe in Kubernetes. The readiness probe is when you first boot, are you ready to receive traffic? Another thing is there's some point in the future where you won't be ready again. The database goes away. What happens when your database goes away internally? Anyone crash the app? Anyone log an exception? Raise your hand if you log an exception. Is that an exceptional case? It's a network on the other side of that. Is that an exceptional case? Mm-mm. You should assume that the database is going to be unreachable at some point. Guarantee it. I will promise you, through the life of your app, the database will not be there. So for you, you should define some of these readiness probes. You log an issue that I tried to connect to this database, you retry, and you mark your readiness endpoint unready because you can't talk to your database. Right? So given that, this is the contract between your app and Kubernetes. This particular app has a couple of components, and we're going to deploy this now just to see how they work. So let's go through this really quickly. So one thing is we're going to talk about secrets, because I want you to take the secrets off of the disk. All right? If you have secrets on the file system, we want to remove them from the file system. There's one way to do it. I'm going to show you one possible way that has some nice tracking features. I don't know if I have time to set this up properly. Anyone use Vault? Anyone heard of Vault? Are you curious? It is. All right, that's awesome. So first thing we have to do is deploy Vault. So an easy way to do it is you can actually test this out in developer mode. Here I have Vault, and I have this Vault container. This is really, really bad what I'm doing. Like I'm putting the Vault root token in here. This is like silliness. But it's good for testing, okay? And then also what I'm doing is doing a single node Vault, but you can actually run it in an HA setup. But we just need the Vault API to start. I have it deployed in my cluster. I'm going to show it to you. And then we're going to integrate it with Kubernetes so we can actually use the identity we get from Kubernetes in our services so that they can actually pull the secrets that they need. We're going to talk about policy as well. So here's Vault running in my cluster, ready to start giving out credentials to my apps. The next thing we need to do is configure Vault. This is not actually that easy, so I have some tutorials online, but I also have this little script that I use to configure Vault. Yeah, you have to do a bunch of stuff. One thing we have to do is be able to communicate with Vault, and then we have to give it a policy file. So here, kubectl get svc -n kube system. So my Vault cluster is available there remotely, so I'm going to be able to connect to it. The next thing that I need to do here is run this command, and I need to make sure that everything in here is right. So I need a few things. I need to be able to connect to my database. Yes, you can hack my database if you're fast enough. And then I need to be able to talk to my Kubernetes cluster. So here I got to wire up Vault to trust Kubernetes to identify my services that I deploy. Most people are deploying services with no identity. File on disk, if you can see it, that's who you get to be. We want to tighten that down a little bit. So one thing we're going to do here is connect it to Kubernetes. So we're going to pick one cluster. I have 3. We're just going to pick one of them. Config. I'm going to show you guys how to do this manually. There's better ways of doing this, but here's how you do it. I'm going to go to Oregon. Oregon's pretty dope. That's where I live. So one thing we need out of this is we need to know where our Kubernetes server is. So I'm going to grab this, and we're just going to configure Vault to use this. All right, so this is going to allow Vault to communicate with Kubernetes and validate service accounts that come its way. Right? And then the last thing I need to do is get the TLS certificate so we can trust the Kubernetes server we're talking to. We'll come here. And then we need to do this. This is what, base64 encoded? Anyone know what you do with these? Here you go. Yep. Come on, just keep it real. You need space. And it's like capital D with this thing. Whoo! His bash skills are sweet. Yes, they are. All right, so we'll do this. People hate when I don't use Vim correctly. I sit there and delete every line. It's like, oh. Give it a count, man. All right, so we put our certificate in there. Now, if we can get to Vault, what should happen is we should be able to configure it. So I'm going to do source. Vault env, so this just connects it to Kubernetes, and let's see if Vault works, so we'll just do status. Great. So we have a Vault cluster, but now we need to configure it with a few things. One is we need to give it policy. So here's this app policy. This says if you identify yourself as an app service, you can read from Vault your database credentials. We don't want to put them on disk, but we want to create credentials, 1 per app instance, right? We're not going to give everyone long-running credentials. If you're a DBA, you're not going to create credentials and give them to people. How many people have had their DBA email them the password? No. Do not email the password. Who are you emailing it to? Okay? So what we want to do is say, hey, the app has an identity. Given that identity, if we trust it, it communicates with Vault and we'll hand back dynamic secrets. And if the app dies, we remove the secrets. Okay? But we need a root of trust. This is also a problem. How do you give a process trust or an identity if it hasn't started already? Well, Kubernetes works with that. We have service accounts. So we're going to go through that flow really quickly. So here's a policy that says you as an app can read from here. So what we're going to do now is just configure Vault really quickly. I'm just going to show you it one more time. We're going to have dynamic SQL creation of credentials. So here's a template that when something wants credentials from my MySQL database, Vault will use this template to mint credentials just for that process, hand it back to that process, and then only allow it to live for 30 seconds. That process must renew these credentials every 30 seconds for them to continue to be valid. You don't renew, the process gets deleted, or the secret gets deleted from the database. Then you have to get a new one, okay? All right, so let's do this. So bash configure Vault. Do not crash on me. You ever see warnings that people say you can ignore? It's like, then what? Don't print it. All right, so hopefully Vault is good. So here's our test. We have this app. And this is a bash job. So one thing I see people not use enough in things like Kubernetes is when you start to break these services out, some things are better off as like a cron job, like straight up old school cron, right? You don't necessarily need a service sitting on an HTTP endpoint doing absolutely nothing. If you want to send email, you can fill up a message queue and then kick off some batch job that pulls things from the queue and kill it. Kubernetes has native support for things like batch jobs. So here, we're just going to run this one job. This is not necessarily a cron job. Notice what I'm doing here. I'm going to talk to Vault. I'm going to give it my identity called app. If Vault can validate that I actually am in possession of a valid service account, then it will give me a token back that I can use to ask for more credentials. So I'm going to communicate to Vault, and then I also need my database password. I could store that, or my database URL. I could store that in Vault, but I'm choosing not to. So when I run this workload, what I hope to happen is that it grabs this service account, talks to Vault, Vault gives it unique credentials, and it's able to ping the database, okay? So one thing we need to do is create a service account, kubectl, create service accounts called app, all right? So now in Kubernetes, kubectl get service accounts, we actually have this new service account, and now we can start to get permissions to this particular role. Some people create them per app instance type, or you could automate it and create it per instance. That would be a little bit overkill for this particular presentation. And then what we have to do is we have to get it bindings. So in this case, I just want this to actually just do very simple, just prove that it's an app and it's called app. So that's already in there. And now we're going to run the app. So here's my database, and I'll go here. So I just have this MySQL database. You'll notice the list of users that I have. I have this sys user, and I have root. And I just have this little database over here that it's going to ping, app database. So what DBAs would do is they would come here, create user, email it to people, and it will stay there forever. This is not how we want to do it. We want to do this based on identity. So let's kick off this job. kubectl apply -f Kubernetes, and then we'll do worker. I'm going to run it. It's pretty fast. So it's running, okay? Now it's gone. So let's look at the user database now. So you see this dynamic user there, right? Right, this random username. This is only good for that process invocation. No other process can use these credentials. Vault won't hand it to anyone else. What is Vault doing underneath the covers? kubectl get pos -n kube system. I'm using a different namespace to run admin tools. So what I want to do here is get the logs for Vault so we can see what's happening. So you can actually use an audit log here as well to keep track of this stuff. So notice what's happening here. My app died, or exited, and it didn't renew these credentials within 30 seconds. So Vault's saying it's expired, and it will clean up these credentials everywhere. My app itself, come on, I can type. Yep. So I want to look at the logs here. kubectl logs here. And then we can see what happened. We start the worker, we load our service account, so Kubernetes puts this service account, your identity, in a well-known location. You can read it, and then you can use it to present to other tools like Vault. Here, once it's validated, I can get my database credentials. This is what it gave back. I pinged the database, everything worked, I shut down. And then we come back here. Oh man, if you're DBA tracking username and passwords in spreadsheets, just nod if that's you, it's okay. Look at the magic here. The app is done, the credentials are gone, okay? So for most people, if you start to have thousands of these little services trying to access different parts of the system, you're gonna have so many username and passwords. Wouldn't it be nice if you can put them all in one place, give them policy, and give them something that expires, so that way you don't have to do password management with files. This keeps it super portable. I could run Vault in a separate system and then have this work across clusters, and I get the audit log. So this is what a lot of people are starting to do in terms of identity, or you can even use this for your app credentials if you wanted to. Vault is gaining those particular capabilities. So that's Vault, and this is how we're starting to think about password management based on identity. You're trading some trusted identity for credentials to the other services that you need. Then the last thing we want to do is talk about Istio. So at a high level, Kubernetes does a good job of keeping our apps running, doing the basics, deploying things, giving us access to things like secrets when we need them. But what happens when we need visibility? Most people here didn't raise their hand about metrics, so we need to see how we can solve that problem. So one thing I want to talk about some of the concepts, and you can go and read all these docs, but here's the overall thing you have to understand about this Istio approach. So earlier, John, I think, was on stage talking about Borg is better than Kubernetes. Why? Because there's a lot missing in Kubernetes. So one thing internally, if you have an app A that talks to service B, today we just do it point to point. How many of you are using TLS between each endpoint? Not many hands. You know why? Because it's hard. Who rotates those things? Who mints them on demand for each process? Did you notice the pattern that we have with Vault? What if we could use Vault to be the CA to do the same on demand every time a process starts, and we give it a certificate, and then it's short-lived. So if someone compromises that particular cert pair, it's gone. So now we can actually do these microservices where they actually have identity, and they carry it over to build this service mesh. So instead of you talking point to point down here, we introduced what we call the sidecar. Now to me, I think this is probably one of the most important patterns for people thinking about doing microservices when multiple languages are involved. So imagine having stuff like in Ruby and Java, but you want to do rate limiting. The chances of you finding a rate limiting library that works the same across both of those languages is minimal. So what you would rather do is try to implement some of this logic in some proxy somewhere. But the problem is if you do it with a centralized proxy, then everyone's beholden either to the same rate limiting policy, you can't fine tune it. So what we want to do is take Nginx, HA proxy, that kind of functionality, and move it next to each process. How many people have heard of a service mesh before? So this sidecar pattern is really important because what we can start to do is we can do things once. Rate limiting, chaos monkey, retry semantics, circuit breaking, all this stuff that's hard to do in a single app, we can put in one place like this sidecar and actually have a single implementation across the board. And we're going to see what this looks like in a moment. And then we have this control plane up here. So in Kubernetes, you notice how we were deploying things. We had a way to say, hey, Kubernetes, here's how I want you to deploy my front-end app. Here's how much memory I need. Here's how you check if I'm alive. Here's how you give me what ports I want to listen to. That all works great, but what about the rest of the stuff? How do you know what metrics to collect? How do you know to track HTTP requests? How do you know that this version of this microservice can talk to that version of that microservice? Most of us don't have any of that kind of tooling. So it's wild, wild west. We have all this stuff deployed, and it's just noise. No one can tell what. So before I deploy this app and start to wrap things up here, I depend on this bar service and this foo service. Can anyone tell me from looking at that what order I talk to them in? The fact that you're even trying worries me. Because how would you know how I'm talking to these services? I could be doing them in parallel. I could be doing them one at a time. I'm pretty sure someone's sitting there that's like, he's probably doing it in alphabetical order. But this is the straight up guessworking that we're doing when most people start to adopt microservices for the first time. There's zero visibility. So how do you get visibility into these apps? Anyone. Anyone with microservices that believe they have visibility, how do you do it? Prometheus. I would say Prometheus Prometheus is a way to collect metrics. You have this endpoint where Prometheus is a tool that gathers metrics and organizes them in the way where you can either like paint pretty pictures, run queries, or set alerts. But the problem is you're still missing some data. There's things you can't see. Prometheus doesn't really tell you that I'm talking to this service and then this one. Prometheus, you could probably reverse engineer from the metrics, but you're probably going to be off. HTTP tracing is a better way to do that particular problem. So this is the app infrastructure that's required if you want to actually do microservices. So here's one container inside of this thing in all of its profiles. Look at this picture. I need to get this sidecar in there. There's one way you could do it. I'm going to run out of time. You got to go faster. Let's get Istio in here. CD. All right. So we got to install Istio now. So one thing we have to do is we have to get this sidecar into our process. One thing we need to do is install the Istio control plane. And remember, when you're going to do this yourself, you can follow the documentation. Like, I remember how to install it. Nope. I straight up copy straight from here. You're going to do the same thing. So we're going to get Istio control plane installed in our cluster. I'm going to run this command to make sure that my personal account has access to do that. And then what we're going to do is we're going to download Istio. And once you have it, you're going to install Istio. I'm just going to take the easy path for now because I want some things to work. And then we go to our Istio directory, and you're just going to install it. There's a lot of moving parts to this, but they get a lot of things right, and they just bundle it all into this one file. Don't even try to refigure it out. Just install it. Things from the internet are good. Just put them in your cluster. Oh, that's some new stuff there. That's a lot more than I accounted for. Oh, you moly, whatever. This is what you do. All right, the other thing that we need to do is we need to make it easy for people to do this. So one thing that has to happen is that this sidecar, remember the sidecar we saw from the photo, it has to live by each process. But what happens if someone forgets to put it there? Well, they circumvent all the security stuff we want, and we may not get the visibility we need. So in Kubernetes, their newer versions, we have what we call an initializer. This is the way for us to decide policy. So even though the developer wants to give me this one file with one container in it, I can inject the sidecar transparently and have the sidecar hijack all the network traffic and force it through the sidecar. You have to do the policy. So the way we do this in Kubernetes is we use what we call an initializer that will initialize the app before it actually gets deployed. So we'll deploy it. All right, the last thing we're going to do now is put on a few add-ons. We want some visibility. So one thing we want is to be able to see things that are happening inside of the cluster. So one thing we can do that is with some tracing. So here I'm just going to use Zipkin. So this will give me my HTTP traces. And then I also want something like Prometheus and Grafana so I can actually see some of the common metrics, okay? So we're going to add in Prometheus. And then we want to graph some of the things that come out of it. So we want to do Grafana. Oh, whatever. kubectl, apply, and then we'll do Grafana. So with these in my cluster now, we have that control plane set up. So now what we need to do is inject the sidecars. So one way of doing that, and this is the old way of doing that, is like this. istio kube inject -f, and we can give it our declaration, and it will rewrite it for us on demand, injecting this sidecar in between, which will do a bunch of stuff to hijack traffic. Problem is, if people forget to put it there, then we lose some of the benefits. So we have that initializer that's going to do it for us. So let's deploy our front end. Then we'll do our back ends. And everything I'm doing here today is app infrastructure. This is basically what we mean by saying all the things you're going to need in place if you think you're going to have a chance of actually doing microservices at all, right? So with these deployed, let's look at something. Notice that this pod is initializing. So this is where we're injecting that sidecar. The sidecar is registering itself with the control plane, maybe getting its TLS certificate, also wiring up any configuration about the other services in the environment, and now we have this sidecar willing to dealing with traffic for us. So the last thing we need to do now is create a front door so that we can talk to these things. And here we need to actually put in what we call the ingress controller. So we need to figure out where's our front door to this service stack. So I'm going to put that in place. The thing here is, like, if you've ever used Kubernetes before, we have this ingress controller. But what we need to do is say, hey, Istio, we want you to take over. So this means Istio will set up its own ingress to handle this traffic for us and give back a public IP that we can use to hit the app. Once that's in place, kubectl get ingress. We'll see this, and if this works, we should be able to ping the app, and I'm going to show you what we get for free when we do this. Now, the good news is your developers have to do very little for this to actually work. All right, sweet. Wow. Here we go, clear. I can write bash. Sleep, 0.5. Bash is the best. That's fine, we don't really need it. Let's just spam the network a little bit though. This is not a substitute for actual benchmark testing. Curl is not what you use for that. So once we do this, what do we get? kubectl get svc-n kubes istio system. When we do this now, you'll see we have Prometheus deployed, Grafana, and Zipkin. So the first thing we're going to do is remember, do we talk to bar first or foo first? Someone say it loud with confidence. You have a 50-50 chance. Bar? Foo. Foo. All right, this is good IT sysadmin we're doing right now. All right, so here's the last bit, so let's like prove it. So what we're gonna do is use actual data to tell us. So before you go down the microservices route, you need some of this app infrastructure in place. We're almost done here. So kubectl get pods-n kube system. I don't have public endpoints for those, so I'm gonna just proxy to this directly. So let's go to Istio system. We're almost done, so I'm not going to keep you too long from your session. We've got like 2 more minutes. kubectl port forward here -n Istio system, and then the IP, the port for Zipkin is 9411. So we'll get a local port here, and I can go to it on my laptop. So we're going to pull this up. Let's see who was right. Who is the best guesser amongst us all? So we click on this, and now we can actually see the trace data. We actually can tell that the front end is talking to bar first. Oh, and what the hell is this? The bar is talking to this mixer thing. What the hell is the mixer thing? But at least you're not guessing now. No one could have seen that I'm talking to these other things without these traces in place. Everything else is guesswork. Then you start to see the latency. Did your app get slower? Why did it get slower? What was it talking to when it got slower? And the last thing that we can also do, and I'll wrap up here, is what we get from the Prometheus data. So what's actually happening here is these sidecars, as you communicate between these services, they're sending up data to the control plane that is then mapping it to whatever you're using, Datadog, Prometheus, Zipkin, and you can add more things at that layer so that as you introduce new microservices into the cluster, with the sidecar, you actually get some visibility for free. So let's do our last piece, which is Prometheus. So Prometheus and Grafana, you're going to get this out of the box. So when you go and try this on your own, the idea here is that you can add visibility to your setup by adopting something like Istio, at least when you start your microservices. I don't want to say journey, such an overly used thing. You can actually do it with some type of visibility to see if you're doing it right. So let's grab this. And Grafana is actually port 3000. Yep, 3000. Let's switch this and see what the system gives for free. Come on. here, and then we'll pull it up. So without doing anything else to the app, just standard, and this will work with any app because we can actually pull a lot of data from many of these. So we pull this up, and out of the box, it's going to at least give you some of the basics and a good starting point for a lot of people. So just by having those sidecars in place, we actually start to see some of the data that's flowing through the system. And since the sidecar actually understands, or Istio understands Kubernetes, you notice that it can actually label the services correctly without us doing any other work, right? We can say, hey, the foo service and the front-end service, it even does things like the version tag. So as we start to do things here, we can actually start to see how the services work, right? So this is how Istio, Kubernetes, and the whole entire stack gives you the app infrastructure you need before you can even think about doing microservices. And with that, end the presentation. Thank you.